students, so here we are gonna learn the numerical based on beta function, and we'll be applying the properties and the definition of beta and gamma function to evaluate the integration. And for that I have a problem for you, that is evaluate the integration from 0 to 1 x raised to 5 square root of 1 plus x square whole upon 1 minus x square dx. Now guys, how to get the answer, how to identify the type, I know these are the all questions which are running in your mind. So guys, first of all, the integration is from 0 to 1 and we have all the algebraic term, so it's very sure that this question is from beta function, because for gamma we require the exponential term, since the definition of gamma function is integration from 0 to infinity e raised to minus x raised to n dx. So for that we require the exponential term, and this question does not have exponential term. So we will be solving this numerical by using the beta function. Now in the beta we have the multiple definitions. Now the question is which definition we must apply over here. So for that I'll show you the different definitions. So one of the definition is beta m comma n is equal to integration from 0 to 1 x raised to m minus 1 minus x raised to n minus 1 dx. Now guys, this is first definition, and the second one is integration from 0 to pi by 2 sine raised to p theta cos raised to q theta is equal to 1 upon 2 beta p plus 1 by 2 comma q plus 1 upon 2. So these are the two definitions of beta, and we have one more definition from 0 to infinity. But for this question, I'm gonna consider these two definitions. Now, if you'll compare this problem with the first definition, the limit is matching, but the other terms are not matching, because we should have two algebraic terms, and here we have three algebraic terms, two in the numerator and one in the denominator. So let's see the second definition. So second definition is in form of sine and cos, or I'll say it is in form of trigonometric function. So if I want to solve this numerical by this second form of beta function, then I must convert my given question in trigonometric terms. And guys, I'm gonna do the same thing. So how to start and how to convert that into trigonometric term? So for simplicity, we will remove the square root from the numerator, and to remove that square root from the numerator, we will rationalize the term which is given in the square root. So let's multiply the term which is inside the square root by the conjugate. So here we will get I equal to integration 0 to 1 x raised to 5 inside the square root, we are multiplying by the conjugate, so 1 plus x square is there and 1 minus x square is there. So the conjugate of this term is 1 here, 1 plus x square, and here it will be 1 plus x square into dx. Now by this, guys, here we will get 1 plus x square, the bracket square, and that will be cancelled with square root. So we'll get I as integration from 0 to 1 x raised to 5 1 plus x square, and in the denominator, see here, we'll get 1 minus x square into 1 plus x square, that is 1 minus x raised to 4, that too inside the square root. So inside the square root, 1 minus x raised to 4 dx. Now guys, we'll solve this integration by the substitution, and for this we will do the substitution of trigonometric terms. So what should we substitute? So guys, since we have limit from 0 to 1, we will substitute either sine or cos, because we know that sine inverse of 0 is 0 and sine inverse of 1 is pi by 2. So we can get the limit from 0 to pi by 2. And similarly for cos. So from cos, we can get the cos inverse of 0 as pi by 2 and cos inverse of 1 as 0. So we can get that limit. So here we will put x square as sine theta. So here I'll say put x square as sine theta. So by doing this, see what happens. Here we have x raised to 5. So we can divide it into two parts. That is x raised to 4 into x. So that one x will go with the dx and we'll get x dx. And for x dx, I'll find the substitution from here. So let's differentiate this. This will be 2x dx as cos theta d theta. So x dx will be cos theta d theta upon 2. So let's put it there. So here I'll say I is equal to integration. We'll take limits afterwards. Here x raised to 4. So since x square is sine theta, x raised to 4 will be sine square theta. In the bracket we will get 1 plus sine theta upon square root of 1 minus, now again x raised to 4. So since x square is sine theta, x raised to 4 is sine square theta. Next dx. So see here I've just considered x raised to 4. So one x is remaining. I'll put it with this x dx, and x dx can be cos theta upon 2 into d theta. Now guys, let's discuss the limits. So here I draw the table for x and then for theta. So for x it is from 0 to 1. When x is 0, this will be 0, sine inverse of 0 is 0. When x is 1, 1 square is 1, and sine inverse of 1 will be pi by 2. So theta is pi by 2. So limit is changing from 0 to pi by 2. Now guys, see here, I can take 1 upon 2 outside. Here we will get integration from 0 to pi upon 2. I can multiply this bracket with sine square theta, so that will become sine square theta into 1 sine square theta plus sine cube theta upon 1 minus sine square theta is cos square theta, and root of cos square theta is cos theta into cos theta d theta. Now guys, here I can cancel this cos theta and we'll get only the sine terms. So here we'll rewrite the terms. So is equal to 1 upon 2 outside. Now I'll divide that integration into two parts to apply the definition of beta function separately. So first part will be integration from 0 to pi by 2 sine square theta d theta plus integration from 0 to pi upon 2 sine cube theta d theta. And now guys, if you'll see, then it is matching with the definition. I'll show you once again. So this is the definition of beta function. So in our definition we have sine term, but we do not have cos term. So guys, no cos term means the power of cos is 0. It means we are gonna consider this q as 0. So here p, it's 2 because sine raised to p theta is sine square theta. So in the right hand side I am gonna substitute p as 2 and q as 0. So 2 plus 1 is 3 upon 2 and 0 plus 1, that is 1 upon 2. So we will get for first term 1 by 2 beta 3 upon 2 comma 1 upon 2 plus. Now let's see the second term. Here the value of p is 3. So 3 plus 1, that is 4 upon 2, which is 2, and here 1 upon 2 since q is 0. So 1 by 2 beta 4 comma 1 by 2. Now let's solve it. So I'll take 1 upon 2 outside. So 1 by 4 inside the bracket will apply the relationship between beta and gamma. So that is gamma 3 by 2, gamma 1 by 2 upon gamma 3 by 2 plus 1 by 2 plus here gamma 4, gamma 1 by 2 upon gamma 4 plus 1 upon 2. So this will be 1 by 4 as it is. Gamma 3 upon 2, here the formula is 1 by 2 gamma 1 by 2 and again one more gamma 1 by 2. 3 by 2 plus 1 by 2, that is 4 by 2, which is 2. So gamma 2 is 1 factorial plus gamma 4, that is 3 factorial, gamma 1 by 2 as it is, upon this will be 9 by 2. So 9 by 2 will be written as 7 upon 2, then 5 by 2, 3 by 2, 1 by 2 and gamma 1 by 2. So guys, here we can cancel this gamma 1 by 2. It is equal to 1 by 2 integration from 0 to pi by 2 sine square theta plus sine cube theta into d theta. Now to get the value of the integration by the definition of beta function, we will separate the integration or will apply the integration separately to both the terms. So here we will get 1 by 2 integration from 0 to pi upon 2 sine square theta d theta plus this 1 by 2 will go inside, that will become 1 by 2 integration 0 to pi upon 2 sine cube theta into d theta. And now guys, we'll apply the definition of beta function. So here we have the definition of beta function. So integration from 0 to pi upon 2 sine raised to p theta cos raised to q theta d theta is 1 by 2 beta p plus 1 by 2 q plus 1 by 2. Now here if you'll observe, then we have sine square theta term, but in definition we have sine and cos term. So when cos term is not there, we consider the power of cos as 0. It means the q is 0 and the value of p here in the first integration is 2. So now in this definition I will substitute p as 2 and q as 0. So this will be 2 plus 1, that is 3 upon 2, and q is 0, so 0 plus 1, that is 1 upon 2. So we will get this 1 by 2 as it is, and for this 1 by 2 beta 3 upon 2 comma 1 upon 2 plus 1 by 2 as it is. Now for sine cube theta d theta, again p is 3, q is 0, so 3 plus 1, that is 4 upon 2, which is 2, and this will be 0 plus 1, so 1 upon 2, so 2 comma 1 upon 2, so that is 1 by 2 beta 2 comma 1 upon 2. And now guys, we will solve this beta function by using the relationship between beta and gamma. So here 1 by 4, the definition or the I'll say the property which has the relationship between beta and gamma is like this. So gamma 3 by 2 into gamma 1 upon 2 whole upon gamma 3 upon 2 plus 1 upon 2 plus this is 1 by 4, again gamma 2 gamma 1 upon 2 whole upon gamma 2 plus 1 upon 2. Now guys, we know the value of gamma half, which is root pi. So we can substitute value for this gamma half, and for this gamma 3 upon 2 I am going to apply one property, and that is nothing but gamma n is equal to n minus 1 gamma n minus 1. So guys, here the value of n is 3 upon 2, so that will become 3 upon 2 minus 1, that is 1 upon 2 gamma 1 upon 2. So this term will become 1 by 4. Next, this 3 upon 2 will be 1 upon 2 gamma 1 upon 2. Then this gamma 1 upon 2 as it is. In the denominator 3 plus 1, 4 by 2, that is 2. So gamma 1 upon 2 upon gamma 2, then 1 by 4 gamma 2 as it is, and gamma 1 upon 2, and this will be 5 by 2, so gamma 5 by 2. So plus 1 by 4 gamma 2 gamma 1 upon 2 upon gamma 5 by 2. Now guys, let's solve it. So the value of gamma 1 upon 2 is root pi. So root pi into root pi is pi. So this will be pi by 2, and into 1 by 4, that will be pi by 8. Next, the value of gamma 2, here I'll use the property of factorization, or which we call it as a factorial, not factorization, it is a factorial. So we know that the gamma n is n minus 1 factorial. So gamma 2 will be 1 factorial, which is 1. So we won't write it here. Then we'll get plus 1 by 4. The value of gamma 2, again by the rule of factorial, it is 1 factorial. Gamma 1 by 2, I'll keep it as it is for some time. And for 5 by 2, I'll use the property, that is 3 by 2, 1 by 2, gamma 1 by 2. Now guys, here we can cancel gamma 1 by 2. Then this will be 2 into 2, 4. I can cancel with this 4. And here we will get 3. So we are getting pi by 8 here, plus here we will get 1 upon 3. And guys, this is the value of integration for the given integral. So here we have evaluated this given integral, and I know that you will like this video. And if you want to learn more concepts of engineering mathematics and more numericals about the engineering mathematics, then do log in to ekida.com today itself to get all the numericals, all the concepts at one place, and you can enjoy the magic of mathematics. Thank you very much.